Okay, so today I'm going to talk about the science of pizza and the science of making bread. So in my bowl I've got a few ingredients. The first is flour. Now the flour is going to provide the main bulk of my dough. I've also got yeast. Yeast is a microorganism, it's a biological organism that will respire and produce carbon dioxide or CO2. The CO2 is what is going to cause our bread to rise when we leave it to prove and when it goes into the oven. As the yeast respires, it's releasing that CO2. That CO2 is then pushing the dough upwards. Now I've also got sugar, and the sugar is there to provide food for the yeast. Because yeast, as it's a microorganism, needs four things in order to respire. So one is food, so that's our sugar. Another is moisture, another's warmth, and the last one is time. Now the moisture and the warmth are both coming from the warm water that I added at the start. Now it's important that that water is warm, so out of the hot tap is absolutely fine because it needs the warmth for the yeast. However, if it's too hot, it will kill them. So you don't want boiling water out of the kettle, that would be too hot, that would kill the yeast. Nice warm water out of the hot tap is perfect. Now, as soon as my dough is come together, I'm going to knead it. And you'll see I've not used any spoons or anything like that. There's no need. I'm just kneading it straight onto the table. I haven't even needed to put flour down on my table because as long as you've weighed and measured your ingredients out correctly, it will have a nice consistency that it will stick together, but it won't stick to the table. And what I'm doing now is I'm kneading my dough. So I'm gently, at first, and I'll get more vigorous as I go, stretching that gluten as much as I can. I'm using the heel of my hand to stretch it, folding it back over and stretching it out again. Because what I need to do is stretch all that gluten, which is that protein that's found in flour, as much as possible. I want my gluten to become strong. So by mixing the gluten with the water, that helps it to become strong, and by stretching it, I'm helping to form nice long chains, and those chains are slightly elastic, and the more I knead my dough, the more elastic those chains are going to become. Now it's important to have nice long elastic chains of gluten because again, when this goes into the oven and that yeast respires and it starts to push my dough upwards, the gluten is going to allow it to stretch, and then as it cooks, that gluten will go hard and that will trap in those air pockets. So even once the CO2 then escapes, there'll be pockets of air trapped by the formation of the gluten and the flour of my dough. Once I'm happy that my dough is the right consistency and I've been kneading for 10 minutes, and it is important to make sure you knead for at least 10 minutes, you might need to knead for longer, then I'm going to leave it to prove. So I'm just going to pop it under a tea towel so it's in a dark place, and I'm going to leave it somewhere nice and warm. Now what I've got in this bottle is a similar set of ingredients to what I had in my bowl. So I've got yeast, I've got sugar to provide food, and I've got lots of warm water to provide moisture and to provide warmth. And hopefully what this will show you, and of course this is being played a lot faster than in real life, is as that yeast in the bottle respires, it's producing carbon dioxide gas. And that carbon dioxide is starting to blow up the balloon. So the balloon is a little bit like our bread dough. This is what will happen both during the proving process, which is happening now, and when it goes into the oven later. While you're waiting for your bread dough to prove, and it's good to leave it for anywhere between half an hour and 2 hours, it's up to you, is to prepare your pizza toppings. You can check that your dough is ready and finished proving if when you poke it, it bounces back to at least halfway the depth that you poked it. And that will show you that your gluten is now elastic enough and that your dough is springy enough and that your yeast has had enough time to work. If not, leave it a little bit longer, make sure it's somewhere nice and warm. Once your dough has had enough time to prove, and your yeast, which is your biological raising agent, has had enough time to respire, and your gluten is definitely elastic enough and you've tested it to poke it, then you can roll it out. As you roll gently away from yourself and give it a quarter turn between each roll. This will ensure it doesn't stick to the table, and it will help ensure that you get a nice regular shape. I'm trying to get mine into an oval because I've got a rectangular baking tin. If you want a nice circular pizza, then you're going to need to turn it a little more often. You might even only turn it an eighth of a turn each time. Now you will find when you're rolling it that it will spring back slightly. Now that is what it's supposed to do, that's good, it means you've got a good texture to your dough, but it just means you're going to have to just keep rolling it out a little bit further than you want it, and it will spring back ever so slightly. But of course when it goes into the oven, it will rise slightly as well. Once the dough is rolled out, then just use a fork to prick it in a few places. This will release some of the air and the carbon dioxide out of the dough when it's baking. And the reason for this is we don't want it to rise too much because it is just a pizza base. If we don't do this, we'll find we have pockets that rise and some that don't, and you'll end up with a lumpy pizza basically. Then you can add your tomato puree followed by your other toppings. I like to add the cheese on top just because when it goes into the oven, that's going to brown nicely. That Maillard reaction is going to happen because your cheese, you've got that fat and you've got that protein, and it's going to brown nicely on top. Of course, if you prefer to have your toppings on the top where you can see them, then that's a personal preference.